Hi guys, this video is for the first IM3 review packet that I handed out. I'm not going to do every single problem. The video is going to get way too long if I do every single one. There is 50 on this packet, but I tried to do as many original problems as possible. There are a lot of repeats, so I won't be doing a ton of repeats. But of course, in class, you can ask as many questions as you need. All right, so let's get started. Number 6 on the paper, I know it's really kind of like number 2. We are going to find the lateral area and surface area of this figure. We're going to round our answers to the nearest whole, and we're going to leave in terms of pi. Your guys' final is going to have multiple choice and most likely in terms of pi, so we'll practice with that. Okay, so the first thing is our lateral area. So our lateral area is all of the figure around the bases, not including the base. So it's this rectangle, the one in back, and then the one on the side, not the triangles. The triangles are the bases. So for our lateral area, we're going to find just the area of 3 rectangles, which is pretty simple. The first one is a 5 by 6. So 5 by 6, I'll just put each one in parentheses. The second one is a 4 by 6. And the last one is a 3 by 6. Okay, so just adding these together will give us our lateral area. So let's do this in our calculator real quick. We've got 30 plus 24 plus 18, and that gives us 72, and we've got yards squared. Okay, so our surface area, we need to take our lateral area, 72, and we're going to add our 2 bases. Our bases are triangles. So we've got 1/2 and then base times height. This is a right triangle, so if I draw it like this, our base is this length right here, and our height is this length right here. So this is base and height. So 1/2, 3 times 4, and then don't forget there are 2 bases. We got to multiply that by 2. Okay, the 2 and the 2 are going to cancel. So really I have 72 plus, this is 12, and that's going to give me 84 yards squared. So I found lateral area and then used that to find my total surface area. Okay, next problem, we are talking about scale factors. So we've got 2 objects, and the scale factor is a 4 to 7 or 4 over 7. And so I like to think of that as a fraction, 4 over 7. And that's going to equal the ratio of the lengths. But we're not talking about lengths, we're talking about surface area and volume. So that means for surface area, I need to square both of those numbers to find the surface area factor. So that's going to be 16 over 49. So this is surface area factor. And then we're going to take that fraction and cube it, and that's going to give us our volume factor. So that's going to be 64 over 340. That's our volume factor. Okay, so we're going to use these factors to find our new surface area and volume. So to find the surface area, we're going to take the ratio, so that's 16 to 49, and we know that equals, our old surface area is 48, our new one is our x. Very similar to our volume, I'll just set that up as well. We're going to take our ratio that we know, so 64 to 343, and we're going to set up a proportion to the volume over the new one. Okay, and then we just have to cross multiply and solve for our variable. So for the first one, if we cross multiply, we do 49 times 48, and then we're going to divide by 16. I'm doing this all on my calculator, and you get 147. So x equals 147 inches squared. That's the new surface area. In this proportion, our x is going to be our volume. So again, we're going to cross multiply. So 343 times 640, and then we're going to divide that by 64. So that gives us 3,430, and then this is volume, so it's cubed. Okay, a couple more problems with surface area. And I'm sorry, scale factor. We've got, we're just going to do the one with volume on this side. So number 8 it says to use the information given to find the scale factor of the figure. So what I'm going to do first is find the volume factor. So I'm going to take the old shape, 5488, and divide it by the new volume. And this is going to give me a decimal if I divide this, but what I can do is simplify this fraction. So these are both divisible by 16. So if I divide top and bottom by 16, so I do 54 divided by 16, that gives me 343. And if I divide the denominator by 16, so right on my calculator, that's going to give me 64, so that's my denominator. Okay, and what I'm noticing here from my previous problem is these are perfect cubes. So this is actually 7 cubed over 4 cubed. And remember, our volume factor is just our surface, or our scale factor cubed. So that means the original scale factor for the lengths. So how the lengths changed from the first to the second figure is 7 to 4, or you could write it as 7 over 4. Okay, then on to the next page, we've got number 10. And number 10 has solid 1 and 2. And what we're going to do is we're going to find the volume factor again, and then we're going to use that to find the new surface area. So again, we're going to take these two numbers. We've got the old volume over the new one. Okay, and I'm going to try and see if these are both divisible by 7. So 3584 divided by 7. Good. And so that's divisible by 7. It gives us 512. So this is equal to 1 over 512. I just simplified that fraction. Okay, 512, we're going to take the cube root of that, because remember these numbers are going to be something cubed. So I'm going to actually write that as 1 cubed over, and then the cube root of 512 is 8. So that means 1 over 8 is my scale factor. Okay, so scale factor is 1 over 8. I know my volume factor was 1 over 512, so my surface area factor is going to be 1 over this number squared. So that means I'm going to take my old surface area, 2, and I'm going to multiply it by 64 to get the new surface area. Okay, so just do 64 times 2, and that means our new surface area is 128 inches squared. So that's your answer right there. All right, moving on from scale factor and our geometry, we're going to move into some factoring and some polynomial work. So this first one, we are going to factor this. Now this is going to take quite a few steps. Remember, you are not done until you have exhausted all your factoring tools. So the first thing I'm going to check, is there a GCF? There is not. So my second step is to use my slip and slide. So I'm going to multiply the 16 by 1. That gives me x to the 8th minus this plus 16. Now I can factor this, but careful here, in my parentheses is going to be an x to the 4th in both, because I know when I multiply those, that gives me the x to the 8th term. Okay, then numbers that multiply to 16 but add up to negative 17, well, that's going to be negative 16 and negative 1. And then remember, last step was slip and slide. You need to now divide by that a value that we multiplied. So divide each by 16. Okay, so I'm going to write now what I have over here. We're still not done. X to the 4th minus 1. And then this fraction right here, we can write as 16x to the 4th minus 1. Okay, now we've got a difference of squares still. So this one I can factor as x squared minus 1, x squared plus 1. And this guy right here I can factor as 4x squared and 4x squared plus 1. Now I've got a lot of factors here. I can still factor these subtraction factors because they're still difference of squares. So this one is going to factor right here as x minus 1, x plus 1. Then I've got to write this one. This one doesn't factor any further. another difference of squares. So this is 2x minus 1, 2x plus 1. And then don't forget to write that very last one, 4x squared plus 1. Now this is a ton of factors, and we are now done right here. Okay. Number 12, we're going to simplify, which, again, as we love to do, requires factoring. So we're going to factor the top and bottom and see if we can cancel anything out in the numerator and the denominator. So this numerator, well, I see these are all divisible by 8. So I'm going to rewrite this as 8 times v squared minus 7v plus 10. And then in the denominator, these all look divisible by 2. Yeah, that's about it. So we can pull out a 2, and now we have 3v cubed minus 10v squared. Oh, and you know what? We could factor out a v too. So I'm going to write a v here. So this is going to make this squared. This is going to make this to the first power, and then this is going to be subtract 25. Okay. So let's try to factor the top first, numbers that multiply to 10 but add up to negative 7. I'm thinking a 5 and a 2. So this numerator is going to be 8, and then v minus 5, v minus 2. And then in my denominator, I've got the 2v. And then right here, off to the side, I'm going to do a quick slip and slide to see how we factor this guy. So we're going to multiply by 3. That's going to be v squared minus 10v, and then 3 times negative 25 is going to be negative 75. Okay, so I've got to think of numbers that multiply to 75, but they're going to add up to 10. So let's see, 75. Oh, you know what? We can do a 15 and a 5. So we've got v, this needs to be negative, so that's going to be negative 15, and v plus 5. Okay. Then we're going to go over here and write what we have. And don't forget, last step is, since we did slip and slide, we need to divide each of these by the number that we multiplied by. So we're going to divide this by 3 and divide by 3. Now I'm ready to write this over here. So this one is going to be v minus 5, and this one is going to be 3v plus 5. All right, good. So now I see some stuff we can cancel. So I've got, I can divide top and bottom by 2. It's going to leave a 1. This is going to leave a 4. And then my v minus 5s. So my final answer, and since we're not doing this one, we can write it right here, is going to be 4v minus 2 all over 3v plus 5. And that's it. So that's your final answer. Okay. Looks like we're going to do the next one. Again, factoring. Let's go through all our factoring skills we have. The first one being a GCF, and I can definitely factor out, let's see, a 3a, and it looks like that's the only thing that all of them have. So let's factor out let's do a negative 3a. And then what's left is an a squared minus ab, and then minus 6b squared. Okay, now this looks just like any other trinomial, but it has variables where usually we just have numbers, but that's okay. So what we're going to do, again, is think about numbers that multiply to 6, but that are going to add up to negative 1. So I'm thinking maybe a 3 and a 2, maybe if the 3 is negative and the 2 is positive. Okay, let's try that out. So negative 3a, and then let's make this a minus 3b, and then a plus 2b. So see how if we multiply these, that gives me negative 6b squared, and then my ab terms, negative 3 and positive 2, would give me the negative 1. So it works. Okay, moving on to number 15. Again, we are going to work with some polynomials, but now we're dividing. Now, I prefer synthetic, but you can use either since we're going to have multiple choice. You just need to get to the answer. So I'm going to set up my synthetic and write all my coefficients right here. 7 is what we're dividing by. So I've got a coefficient of 1, negative 15, positive 61, and negative 32. I didn't need any placeholders because I have to the third, second, first, and to the 0 power. So no placeholders are needed. All right, so synthetic division. We're going to bring down our leading coefficient, multiply, and add. So that's going to give me, it's a negative 15 and a positive 7. And so that's going to be a negative 8. Then when we multiply, so I've got a 7 times negative 8. That's a negative 56. And then we're going to add those together. So that gives me positive 5. And then last step, 7 times 5. Add them together. That gives me a positive 3. And that's our remainder. So this is not a factor, but that's okay. We were just dividing. So we write our answer. Remember, we're going to write our new polynomial. So this is 1n squared minus 8n, and then plus 5, with a remainder of 3. Now, a lot of people will do the 3 divided by the original polynomial. Depending on what your answer is going to look like on your final, it could change up, but just know that our remainder was 3. Okay, moving on to some graphing with some polynomials. Well, these are actually our cube root functions. And so what we're going to do is think about our original cube root function and then how this changed. So this is going to be to the left 4, down 3, and then we're going to multiply all our y values by 3. Okay, so let's move that center point first. So we're going to go left 4 and down 3. And with our cube root, normally we go over 1 up 1. Now we're going to go over 1 up 3. And then since it's cube root, my next important point or special point would be over 8 up 2. But now we're going to go over 8, and then we'll multiply that by 3. So up 6. 2, 4, 6. Now I'm only doing the positives for now just so I can get this side of the shape. So I'm going to now connect these. Make my point down here and connect it there. And that's your cube root with a transformation. The next one is a square root. So again, think about what would my square root look like, and then apply the transformation. So this new starting point is going to be left 3, up 3. So left 3, up 3. And what we're doing here is multiplying all our y values by negative 1. So usually I'd go over 1 up 1. Now I'm going to go over 1 down 1. And then normally I would go over 4 up 2. Now I'm going to go over 4 down 2. And you can keep going, but this is good enough. And then connect our points, make sure we have the shape of a square root function. Okay, last one on this page is going to be number 18. This says state the possible rational zeros, and all you have to do is take the factors of the constant, so plus or minus 1, plus or minus 2, and we're going to divide by all the factors of the leading coefficient, which is just 1. So this is over plus or minus 1. So if we were to list these as just numbers, it would be plus or minus 1, plus or minus 2, and that's all we have when we divide them by plus or minus 1. When we try these out, so we have a total of 4 that we can possibly try, you're going to end up finding that 2 is actually a zero, a rational zero. So I'll show you how that works. So we would bring 2 out. You can use either division method, but I would use synthetic. And we're going to write our coefficients here, 1, 4, negative 11, and negative 2. And we're going to make sure that we get a remainder of 0 to see that this is in fact a rational 0. Okay, so bring down the 1, multiply, and add. multiply and add, multiply and add. And we do in fact get a remainder of 0. So 2 was definitely a rational 0. And that ends up being the only one. Okay. On this page, we're going to do number 20. We're going to simplify. And so this is multiplication. So remember, first step with these rational expressions, we're going to factor to see if things cancel and then simplify. I definitely notice I can factor this binomial right here. So I'm going to rewrite the first one, 1 over p plus 4, write this in parentheses, times. And then this one right here factors as a 4, and then p plus 4 is left. All over p plus 1. Since we're multiplying, anything in the numerator and the denominator will cancel. So we've got these p plus 4s, those factors will cancel. And if we multiply across, we get 4 over p plus 1. Then you're done. Next one on this page, quick one, just reminding ourselves of our exponent rules. If we multiply something with the same base with exponents, you just add the exponents. So this is going to equal y to the 4th. If they had been 3 and 2, this would be 5. So you just add the exponents. Okay, and then last one we're going to do on this page is a equation with a square root. So if I don't want the square root right here, I don't know how to solve it with that in the equation, then we're going to, in other words, get rid of it or undo it by squaring both sides. Now don't forget, sometimes when we square both sides of an equation, it could create extraneous solutions, so we will check that at the end. Okay, so if I square this, this is x minus 5 times x minus 5 equals, and then when I square something in a square root, all I have left is what was underneath, so 7x minus 45. Okay, so let's square these right here. So I've got x squared minus a 5 and a 5 would be minus 10x, and then plus 25. And then we have our right side of our equation. Now if I want to find what x equals and I have an x squared, then I'm going to try to factor it. Factoring it will tell me what my zeros are or what my x can equal when the function equals 0. Okay, so let's get everything to one side of the equation. So I'm going to minus 7x and add 45. So I've got x squared minus 17x, and then if we add 45, that's going to be plus 70 equals 0. And I'm noticing factors of 70 that add up to 17 are 7 and 10. So if I want to factor this, I'm going to write this as x minus 7, x minus 10. So I've got two possible answers. X could equal 7 or 10. I do have to try both. So what you're going to do is take the 7 and you're going to bring it to the original equation and substitute it in and make sure that it makes a true statement. You're going to do the same thing with 10. You're going to substitute it into the original equation and make sure it makes a true statement. Now for the matter of time, I'm going to tell you guys, which problem is this, number 24. So just for the matter of time, I will tell you that 7 and 10 are both answers. They are solutions, they are not extraneous. So if you check both, they will make true statements. Alrighty. Last page, oops, just kidding, we have a couple more. This is page 3 in the second part of the packet, but this is number 25. Write a polynomial of a least degree with integral or integer coefficients with the given zeros. Okay, so the first thing I want to do is just write f of x, which is my polynomial, and then I'm going to start with this one. If this is a 0, then my factor is x plus 1. If this is a 0, now this is all 1 0, this is x minus, and then write the entire thing. So negative 2 plus root 2. And then if we have an irrational 0, it comes in a conjugate pair. And so that means we also have the 0x plus. And then we've got negative 2 plus root 2. Okay, if we simplify that, we've got x plus 1, x plus 2 minus root 2, and then x minus 2. Now, last step, and you may have to do this on a test or a quiz, is sometimes you have to actually multiply these out. So we would use our distributing skills and multiply these two together, then these two. But I'm going to leave it just like this for now, and we will talk about what would be on the final. All right. On the term of multiplying, we are going to do that in this problem, so you can at least see how we would do that. So what I'm going to do is take this first term and multiply by both in my binomial. So this is going to give me 42b to the third plus 28b squared. Then I'm going to take this second term and multiply by both. So I've got plus 36b squared and then plus 24b. And then last, I'm going to take my negative 7 and distribute. So I've got subtract 42b and then subtract 28. Go ahead and combine any like terms. I only have one b to the third term, so that's 42b to the third. Then I've got a couple b squareds. So if I add those, that's going to be 28 plus 36. That's 64b squared. And then we've got a negative 42 and a positive 24, so that's minus 18b and then minus 28. Okay, so that's what you get from multiplying. Alrighty. Next problem, we are dividing. And so remember, this is like multiplying this reciprocal. It says state the excluded values. So I'm going to do both. I'm going to do the problem and state excluded. So let's factor anything we can first. We're not doing this problem next to it, so we're going to use a lot of that space. The first binomial I see right here, we can factor out a 10x squared. And what's left is an x minus 2. Okay, then the denominator. I can factor out a 9. That leaves me an x minus 4. And then we're dividing by x plus 4 all over. Ooh, and this is a difference of squares. So this is going to be x plus 4, x minus 4. Okay, so my excluded values are going to be anything that makes the number I'm dividing by 0, so numerator or denominator, and then also what makes this denominator 0. So x cannot equal, just write it over here, negative 4, positive 4, and that's going to be what makes this 0 too. So that's it. All right, then we'll actually go through and do this math. So what we're really doing is multiplying by this reciprocal. So I'm going to rewrite this. 10x squared times x minus 2 all over 9 times x minus 4. And then we're going to multiply, and we're going to flip that second fraction. So x plus 4, x minus 4 all over x plus 4. And let's go through and see anything that we can cancel. So we have these x minus 4s and x plus 4s. Okay, let's write what we have left. 10x squared times x minus 2 all over 9. And then you're done. Okay, we've got a factoring problem again. This one, we might be able to use grouping, so let's try that out. So let's try to group this first group. We could factor out an x to the 4th. That leaves an x squared minus 2. And then here I can factor out a negative 4. So minus 4, that leaves me an x squared minus 2. Okay, so then using our grouping method, this is really x to the 4th minus 4 times x squared minus 2. And this is a difference of squares, so I can still factor this one. I'll show you off to the side real quick what that would be. That would be x squared minus 2 x squared plus 2. So that's just for this one. And so we can write that all out as, we'll write this one first, x squared minus 2. And then our other one factored was x squared plus 2. And then another x squared minus 2. So that's completely factored right there. Okay, 2 more on this page. We're going to perform this operation right here, which is g of h of x. And so what we're going to do is find, we're going to take the first function and we're going to substitute the second one in for x. So, oops, our lights just turned off. There we go. So we're going to take 4x, and then instead of x, I'm going to write the second function, 3x plus 4. So when I distribute my 4, I get 12x plus 16. So g of h of x equals this right here. Last one on this page, we're going to check and see if we can do this subtraction and solve this equation. We're going to check again for extraneous solutions at the end. Now, I don't want any of these denominators anymore. I know my LCD is 6v, because I know if I multiply all 3 of these fractions by 6v, I will no longer have any denominators. So let's go ahead and do that. So we're going to multiply this by 6v, this one, and this one. So when I multiply the first fraction by 6v, these are going to cancel, and all I have left is a v minus 1. Subtract. And then when I multiply the second fraction by 6v, just the v's are going to cancel, and I still have the 1 times 6. This is minus 6 equals. And then last equation, again, those v's are going to cancel, and I have a 6 times v minus 1. So this is going to be really simple to solve. So we've got v, and then negative 1, negative 6, that's negative 7. And then on the right side of the equation, if I distribute my 6, I have a 6v minus 6. We're just solving for v. So let's, I'm going to subtract v from both sides and add 6. So it's going to give me negative 1 equals 5v, and then divide both sides by 5. So I've got v equals negative 1/5. Okay. And then again, if you want to check for extraneous solutions, you substitute negative 1/5 into the original equation. And just to check, that's number 32. That is in fact a solution. It is not extraneous. So we've got our solution. Okay, moving on. To find the inverse of this function, we have to switch x and y, but in this equation we don't have any, so I'm actually going to write this as if there were x's and y's. So I'm going to switch x and y. So x goes here, and y goes here, and then we need to solve for y. So first I would add 1. I would divide by negative 2. So y to the 5th equals x plus 1 over negative 2. And then last step, take the 5th root of both sides of the equation. So my inverse is going to be the 5th root of x plus 1 all over negative 2. Okay, then we're going to move down and do number 38. We are going to solve this equation. Now I want to find what x equals. I've got to isolate x. The first step, really easy, just subtract 1. So I've got x minus 8 to the 3/2 equals 27. And then what I'm going to do here is I am going to rewrite this a little bit using my exponent rules and what I know about radicals. So this is really like the square root of x minus 8 to the 3rd. So here's what we're going to do. Square root of x minus 8 to the 3rd. We're going to square both sides. Okay, so I've got x minus 8 to the third equals is going to be a big number, so 27 times 27. And then this is a cube, so we're going to take the cube root. And that ends up being 9 if we take the cube root of this answer. So this is x minus 8 equals 9, and then just add 8 to both sides. So x equals 17. I would definitely check to make sure that that is an extraneous solution. So substitute it back into your original equation. Let me check real quick to make sure. That was problem 38. And 38, that is in fact a solution. So it's not extraneous, so I can circle that. Okay, last one on this problem that we're going to do is this one right here. This is subtraction, and so I need to have common denominators. And so I first have to find the LCD. Let's factor this and see what this is. This is like a 10k and then a k minus 1. And then we have a 3. So all of our factors are 3, 10, k, and k minus 1. So that's 30k, k minus 1. All right, so we already have all of our factors except the 3. So this first equation, or I'm sorry, this first fraction needs to be multiplied by 3. So that gives me 6k over 30k, k minus 1, minus, and then the second fraction needs to be multiplied by all of these terms right here over themselves. So that's going to give me 20k, k minus 1, over 30k, k minus 1. Then we're going to do our subtraction, so just subtract the numerators. So this is 6k minus, this would be 20k squared, and then plus 20k, I distributed the negative, all over 30k, k minus 1. Okay, and then you could definitely combine those like terms. So this would be negative 20k squared plus 26k all over, and then that same denominator, 30k, k minus 1. Okay, you could divide or simplify, divide everything by 2. Those are definitely all divisible by 2. And so that would just change these numbers. It would change the negative 20, the 26, and the 30. All right. Now we are on the last page. We're going to do 2 more problems together. The first one is 45. We're going to use our exponent rules. And so remember, when we raise a base raised to a power to an additional power, that's our power rule, and we multiply these. So that's going to give me p to the 6 times 3 over 2. Now, if I multiply, that's going to give me divide by 2, divide by 2. That's really just a 3 times 3. And so this is going to be p to the 9th. Okay, and last one, we'll end on a factoring problem. We're going to factor this. Again, this is a trinomial. There's no GCF, and so I'm going to go straight into breaking this up into binomials. So I know this is an x squared to give me that first term, and then multiples of, factors of 8 that add up to 2. It's not 8 and 1, and so it would definitely have to be a 4 and a 2. So that would be plus 4 minus 2. Now this is not a difference of squares, so we would leave it as is. Okay, that's it, guys. If you have any additional questions on problems I didn't go over, make sure to ask me either in the comments or in class. Thanks, guys.